Hi, I'm Dr. Christopher Sutton, and welcome back to my Introduction to GIS video series. This is the first of 4 videos introducing you to GIS data. GIS data enables us to map, analyze, and understand the world around us by representing geographical features and their characteristics. In this video, I will introduce the primary types of GIS data. All organizations have a core mission, and geospatial data can play a large role in supporting this core mission. How can we see GIS data used by organizations? Firstly, GIS data supports strategic decision-making. Organizations use geospatial data to analyze trends, patterns, and relationships within their operational context, enabling smarter, data-driven decisions. Secondly, GIS data helps organizations align operations and organizational goals. Spatial data helps organizations allocate resources more effectively by identifying areas of need, opportunity, or risk. Thirdly, GIS data facilitates risk management and resilience. Organizations use spatial data to identify, assess, mitigate, and respond to risks while enhancing an organization's ability to withstand and recover from disruptions. GIS plays a critical role in spatially analyzing hazards, vulnerabilities, and responses. There are many ways we can ensure that the data we use in a GIS project is appropriate for the task. Ensuring that GIS data have high precision, are up-to-date, and are comprehensive is critical for reliable spatial analysis and decision-making. Accurate metadata, correct coordinate systems, consistent formatting, and minimal errors are essential for meaningful GIS work. GIS analysis requires data integrity. Investing time in acquiring, verifying, and maintaining high-quality data sources directly impacts the effectiveness of GIS applications. In many GIS projects, we spend considerable time cleaning, standardizing, and validating spatial data before analysis even occurs. GIS data is commonly divided into spatial data and non-spatial data. Spatial data defines the locations and shapes of features. Non-spatial data describes the characteristics of spatial data. When working with GIS, it is important to remember that spatial data is not a perfect representation of reality. Instead, it is a simplified model designed to help us understand the world. What does it mean to say that GIS data is a simplified model? The answer can be found in 3 key characteristics of spatial data: selectivity, approximation, and generalization. Spatial data is selective because it does not capture everything. Instead, it focuses on the most relevant features for a specific purpose. For example, a transportation map might highlight highways and major roads but ignore small alleyways. Every GIS dataset is designed with a specific goal in mind, meaning some details are deliberately excluded to keep data manageable and useful. Spatial data is also approximate. The world is infinitely detailed, but GIS data must simplify this complexity to be usable. No matter how precise, every dataset contains some level of inaccuracy, whether due to measurement limitations, changes over time, or errors in data collection. Spatial data is generalized to make it easier to analyze and interpret. This means that fine details are sometimes simplified, smoothed, or aggregated depending on the scale of the map. For example, a river may be represented as a single line on a small-scale map, but as a wide polygon on large-scale maps. Similarly, a country boundary may appear as a smooth line even though its actual borders may be irregular or disputed. Generalization helps reduce visual clutter and ensures that the data remain meaningful at different scales. We have 2 major categories of spatial data. The first is vector data, which is made up of points, lines, and polygons. The second is raster data, which is composed of grids and images. Both vector and raster GIS data will be covered more extensively in upcoming videos. Related to these categories are the discrete and continuous nature of spatial data. Discrete data represents objects with clearly defined boundaries or locations. These features exist in specific places and do not gradually transition from one to another. They can be represented in GIS as points, lines, or polygons. Examples include trees, individual buildings, roads, and administrative boundaries. Because discrete data consists of distinct entities, we can count and classify them, making it useful for tasks like mapping infrastructure, analyzing land ownership, or planning transportation networks. Continuous data represents phenomena that vary smoothly across space and have no distinct boundaries. These values change gradually, meaning that they exist everywhere rather than at specific locations. Examples of continuous data include elevation, temperature, and air quality. Geographic information systems are powerful tools for mapping, analyzing, and visualizing spatial data, but working with GIS data comes with challenges. To make accurate and reliable decisions, GIS professionals must navigate issues related to data quality, data integration, data management, and data accessibility. Data quality issues are common in GIS. Poor quality data leads to inaccurate maps and flawed analysis. If coordinates or attribute values are incorrect, the results of GIS analysis may be misleading. Data collected at different scales may not align properly, causing errors. Missing data can create gaps in analysis, leading to incorrect conclusions. Outdated GIS data may not reflect current conditions, making decisions unreliable. Another challenge with using spatial data involves data integration. GIS often combines data from multiple sources, such as satellite imagery, field surveys, and censuses. Integrating these data sets is not always easy. Different organizations use different file formats like shapefiles, GeoJSONs, or raster grids, requiring conversion. If you attempt to integrate spatial data using different coordinate systems, layers may be misaligned. Handling GIS data efficiently is another challenge, especially as datasets grow in size and complexity. Proper data management is key to ensuring that GIS remains useful and efficient. Challenges related to data management are among the most common for GIS users. Data management challenges include storage issues. Spatial data oftentimes is very large in size and requires significant storage capacity as well as efficient organization. When using large datasets, processing, querying, and performing analyses can take considerable time and maximize the capabilities of the computer that you are using. Finally, there are challenges related to accessibility. Even when high-quality GIS data exists, it is not always accessible. Barriers to accessibility include restricted access, where GIS datasets are proprietary, requiring expensive licenses or permissions to use. There is technical complexity. Not all users have the expertise or tools to process and analyze GIS data. And finally, there are connectivity issues. Remote locations may lack internet access, making it difficult to retrieve or update GIS datasets. This wraps up our introduction to GIS data. In the next videos, we will cover vector data, raster data, and non-spatial data.